This movie provides an example of how you might create a reasonably complex button pad package. We've taken a screen grab of the dimensions from the datasheet and saved as a bitmap so that we can import it into the layout for reference. We're going to make the 5mm version of the footprint defined at the top of the table. Let's start by creating the necessary pieces. We will need several pad styles, one for the ball pad in the middle, then a couple more for the terminating pads. The main difference with these styles is that we are creating them with no paste mask, as there are actually no surface mount component being placed here. It's good practice to suffix the pad styles so that this is clear. Finally, we need a 1mm track to route round the circular pad and connect the two 1mm pads. Looking at the land pattern, we're going to need to draw some guidelines for positioning and routing. We'll modify the default graphic line style to be thinner and then use graphics on the mech layer as our guides. There are some fixed 45-degree angles on the track, so it will be easier for us to control with Follow Me routing switched off. Follow Me routing is ideal for tracking a board as it's more freehand and obeys design rules. In this case, however, we want to track strictly on a grid in clearly defined steps. Finally, we need to make sure that trace angle lock is switched on to ensure 45-degree cornering, and we should switch track necking off because we don't want to neck into the terminating pads. We'll start placement with the center ball pad and place this directly on the global origin to simplify measurements later on. Looking at the guide, we also need a 0.4mm track out to the centre of the pad. We'll create a new track style for that in the usual way, and then place the track out from the pad without worrying about the termination pad. Next we have to set the minimum escape clearance from the track. If we make this clearance 0.8mm and add on half the width of the place track, that gives us vertical clearance of 1mm from our origin point. This can be shown by placing a couple of guidelines, making sure to switch the coordinate systems to metric in order to measure the distances. If it's tricky to place the line in the correct place, it probably means that the snap grid needs changing. In metric mode, the third snap level, F3 on the keyboard, is a 1mm grid that suits us perfectly. The coordinate display at the bottom right can be used to confirm placement, but with the correct snap setting it's simply one grid square from centre. Now we do a little maths to get a placement grid for the track. The trick here is to set our guidelines in the midpoint of where the track will go, as this is where the mouse position is during routing. Starting with the outside box, we can see from the D parameter that our maximum distance from origin is around 2.6mm. We need to subtract half of our trace width from that to align the guide to the desired mouse position, so we want a box 2.1mm out from the origin. For this level of granularity, we need a finer snap grid. Then using the coordinate display to guide us, we find the top left corner and drag out a box of the correct size. Next we need some guides for the 45-degree corners. We take the T parameter at 1.7mm and again subtract half the trace width to give us a 1.2mm offset from the origin point. Again, the coordinate display will verify the position before placing, but at any reasonable zoom level, the grid display will help navigate to the right starting place. Having finished the setup, we can start placing the remaining pads and tracks. Using pad mode, we place the two pads against the minimum clearance line and in the middle of the outer guidelines. Switching to track mode, we line up the mouse against the intersection of the outer guideline and the 45-degree guideline. Left click to start placement and then use the guidelines to place the track and terminate at the pad. Now we go back and complete the connection from track to top pad in the same way. Turning off auto track necking is important here to avoid necking into the pad. To tidy up the centre track, we move it backwards, place the termination pad and route to it to make the connection. We also need to number the pads. Connected pads get the same number. in our case number 1 for the 2 ring pads and number 2 for the other 2 pads. The final job is to control the resist for the land pattern. We are aiming for a large escape around pretty much the whole component. We select 2D graphics path, switch the layer to the top resist, and then trace a path just outside the bounding track. When the path is complete, set the fill style to solid. The 3D viewer is a useful way to check that everything looks correct before making the part. We need to draw a board edge and then simply launch the 3D viewer from the module toolbar at the top of the application. Once satisfied that everything looks fine, we are ready to make the package. We can either delete the grid on Mech 1 or simply hide the layer before we create the part. It's important to switch to selection mode before selecting the part from Make Package and compiling the part into a library of your choice. It's often recommended that these land patterns allow for venting via a drilled centre. We could add this easily by dropping a via over the centre pad and then remaking the device. Depending on the manufacturer's spec, and provided a connection can be made from the other side of the board, this would actually greatly simplify the rest of the land pattern. Once we are finished, we can then delete our graphics and place the packages directly on the board. Other similar types of packages, such as finger meshes, are actually much simpler and can be created using exactly the same techniques.